Good morning, everyone. My name is F.Khourbiga. I've worked on this project with E.Deligne. It didn't manage to come today. What is Sandbagility? It is a framework entirely written in Python to perform some introspection and analysis for security research purpose. The talk will focus on malware analysis, but you should keep in mind that it's not really restricted to this approach. Let's introduce myself. I've worked for many years in reverse malware engineering in French administration with Eddie. We've worked at the French Ministry of Armed Force, and we have to deal with some malware. And we decided to start this project based on work made by Nicolas Couffin. I will talk about it more later. First of all, I would like to start with a live demonstration because I hope it will help you to understand what I'm talking about and to have a better understanding of why I'm here. Okay. Sandbagility takes place with a modified version of VirtualBox. The hypervisor was modified to implement virtual machine introspection protocol called fast debugging protocol. The most important thing to keep in mind is I have no backup plan. And the framework is entirely in Python, so you can use it through the IPython console. It could be useful for some stuff that you have to do manually. The first thing is to start a connection between your framework and the guest. The guest is, there is no agent, no program, no driver. Even the /debug mode for the kernel is not enabled, so all the actions are performed outside the guest and without his cooperation. So if we want to set a breakpoint, just set breakpoint with the function name that you want to trace and let the virtual machine run. You should regain the control. For each call to anti-write file, the RCX register contains the handle value that represents the file which is accessed during the write action. So it's interesting, but not enough, because you want to know which process is currently accessing this file. There is a function ps_get_current_process that allows you to get some information about the active process, and you can just check the process name like that, and okay, it's VBox service that is currently writing a file, but at this point, we don't know which file is accessed. So we have a method that allows us to convert any handle of a process to its friendly representation. So from there, we did some actually introspection of the guest without any cooperation. But the Sandbagility, the framework, was not really designed to be used only by the interactive mode. So you can write some script, as you can guess, and just dump all the processes, all modules loaded, and all drivers. So this is the first part of the demonstration. Okay, that was good. It works. So here is the agenda for this talk, a brief introduction to malware analysis, state of art, and introduction to fast debugging protocol. Then I will speak about our objectives in this project and the architecture that allows us to have a more work to do to support more build of Windows or maybe other operating systems. And how we managed to perform the introspection and how we filled the semantic gap. There is mainly three approaches, static, dynamic, and automated approach. The automated one is more like a sandbox's solution. The static analysis is maybe the slowest one. You have to sometimes do the reverse engineering based on the assembly language. The dynamic analysis is more black box approach based on input-output on the system, and you put some maybe honeypots to interact, or and you can also do some debugging. The last approach, maybe the fastest one, is based on sandboxes. You just put the malware in your sandbox and you have a beautiful report, sometimes quite frightening. So this is the case when the malware is executed inside the sandbox, but sometimes it's not the case. So you have to go back to the dynamic analysis, which could be much slower, and sometimes to the statistical analysis. So Sandbagility was more designed to be an hybrid approach between the dynamic and automated approach to hope to gain some time during the analysis. First, we tried to find something that could fit our needs. In sandbox approach or solution, we are maybe at the third generation of sandboxes. The first one were designed to put some programs, agent hooks inside the guest at the user space or kernel space level. But as you can guess, this approach are too exposed to malware that can detect or defeat them. So maybe the state of the art of the approach is to have an hypervisor to allow this introspection of the guest. There is few solutions to allow this kind of introspection and to be interactive enough for this kind of analysis. So we have Pyrobox, which is a quite good framework based on QEMU, volatility, and on Linux. And we have also found a Dwargwoof, which uses libvirmi and Xen, also based on Linux. There was another solution, which is the fast debugging protocol. As I said earlier, this is a modified version of VirtualBox to implement some few functions to allow this introspection. The author, Nicolas Couffin, has focused on the performance and tried to do the fastest protocol as possible. And he designed some connectors to connect GDB or WinDBG to its protocol. So fast debugging protocol, like I said, is a VMI library that allows you to read-write registers or specific registers like the MSR, or you can access the memory, full memory of the guest, and also inject interrupts. And some bonus features like saving and restoring the guest on the fly. Okay, the performance really quite good, because we can hope more than 100 instructions per second in step-by-step mode, or more than 25,000 hits per second for the fastest breakpoints implemented. More you can hit a breakpoint per second, more it can be useful, because you can trace all the syscall from a malware activity. So from that, we can write the Sandbagility framework without considering too much the loss of performance, because we don't have to keep this in mind. So our objective, like I said, is to have a framework between dynamic and automated analysis in order to reuse what we can find on previous malware, and also to to stay still as possible during the analysis. That's why at any time we doesn't use any kind of agent or in shellcode or any kind of this technology to interact with the guest. And maybe the most difficult objective is to keep it simple. Here is the architecture. As you can see on the right, there is some guest that you can run on VirtualBox, the modified hypervisor with the implementation of the fast debugging protocol is released with a binding, Python binding, that we put on an abstract layer, a core abstract layer. This abstraction allows us to develop or to implement other VMI library like libVMI, so maybe we will work on it. So above this core layer, we have another layer, which is the helper. The helper is constituted with two layers. The OS helper is more specific and more guest-aware to perform the introspection needed by the framework. So is aware about the object manager or object of Windows, like eProcess, eThread, file object, and so on. The helper will provide some high-level API to perform some symbol lookup or set breakpoints. The last layer, maybe the more useful for the analyst, is composed of two kinds of classes, monitors and plugins. The monitors are designed to allow you to trace any kind of event inside the guest. The other plugins are designed more to perform some actions on the guest. For example, here is an output of two monitors, one in kernel space and the other one in USERLAND. On the left, you have the kernel monitor output, and on the right, the USERLAND monitor output to trace operation on reading file. Here is the code needed to perform these actions. Actually, you just have to declare which kind of monitor you have to use, if it's a kernel or a USERLAND monitor. Declare your dependencies and set breakpoint. And the monitor will do some magic stuff to start from the symbols, get back the prototype, read the parameters. And okay, it's quite too easy. But to have this all these capabilities, we had to do a lot of introspection and to understand how Windows manage each kind of subsystem or space, like kernel, USERLAND, but also the system, the Windows on Windows subsystem. All the traduction of symbols are performed using the DBG help, but I will speak on it later. And as I said, when you set a breakpoint on a function, and if this function is declared on headers, bundled with the framework. The framework just get the prototype of the function and perform the reading of parameters in input and output, so you have all information without doing anything. Another concept, which is the delay loading. For example, if you set or create monitors that need to interact with a module that is not loaded at the time when you launch your monitor, you have to wait for the module to be loaded, so you have to create a kind of notification from the hypervisor when the guest load the module. If you have all this stuff, it's pretty good, because you just have to handle the page fault when sometimes the system have to swap to put some physical memory region into the page file, and if you try to read at this virtual address, the VMI library, the FDP protocol, just give you nothing, because the memory is not in memory, but on the disk. So we inject interrupt to force the page fault handler to swap off the disk, the memory. Another demonstration. That's what we call the hypervisor-based application programming interface. So you have a script, Python, hyper-IP, okay, some debug line, and as you can see, command prompt just spawned, and if I can zoom so you can see. Okay. Maybe it's too. Okay, I hope you can see. The CMD prompt is under the anti-authority system. So this is performed from the hypervisor level without any kind of agent. If we take a look at the script, this is actually the complexity to write that. We get an API, our hyper API, and we just call some win32 function from the hypervisor. So just create file, write file, close, and then win exec. So you have your arbitrary execution on the guest. You have some few actions to perform that, but if you do it, just run any kind of action on the guest. So the semantic gap is, where am I? Okay. What is the semantic gap? The operating system runs inside a virtual machine, so is not really aware that an hypervisor is running under him. Meanwhile, the hypervisor works without knowing what the virtual machine does. So this is what we can call the disruptive model between the hypervisor and the virtual machine. This frontier between these two components are what we call the semantic gap, and we have to fill it in order to understand what the guest is doing. We have some information three kinds of information to have in order to understand what the guest is doing. We have the semantic of the operation, the action that the guest is doing. You have also the identity and the resource to found. First thing, you have to get some semantic about the operation. The operation is quite easy to have because you are setting a breakpoint, so you know, I hope, that when you set a breakpoint at this address or symbol, that what kind of action it is performed. So to fill the semantic gap, we have three first actions to perform: locate the kernel, identify its version, and load the according PDB files. To find the kernel, we rely on MSR register, MSR L* register, which contain a virtual address of a function called KI system call 64. If you have this function address, you know that you have an address inside the kernel region. So you just have to go up and find the file header. When you have the file header, you just go through all the structure until you find the RSDS debug format and get some information from it to reconstruct the path for local loading or from the Microsoft server downloading. From that, we rely on the DBG help library, which called DBG help.dll, to handle and resolve all the symbol or get the data type structure and convert them into a Python object. So at this moment, we have quite the same capabilities of WinDBG. Another demonstration is that we can go maybe deeper than WinDBG and maybe easier. For example, when you are performing some malware analysis, you have to watch what's going on and who is dropping a .exe file. So if I'm writing MC inside a file, as you can see, the script can catch the operation and give you some information. It doesn't matter which processes is doing this action, you just getting it, so from outside. Okay. The second information we need to perform the introspection is to find the identity of the process that is actually doing the action. There is two ways to find this information. From the right, you just go through the double-linked list of process, which can be useful if you want to enumerate all the processes running on the system. But if you want to get faster the information about the current processes that is performing the action, the other path from the left is better because you start from the MSR GSBase or MSR kernel GSBase and go through the KPCR, PRCB, and threads, and you can find the eProcess object and find the image file name and all information that can be friendly for the analyst. So the last information that we need is to have some information about the resource which is accessed by the process. Under Windows, a lot of resources are represented by a handle value. This handle is returned by the system when you ask him to create, for example, a file. When you create a file, you call a function called createFile with the file name that you want. The system will apply some security check, and if you have the good rights, it returns a valid handle. Based on this handle value, you can perform some operation like reading, writing, and so on. And when you have done, just close it to release some resource. So the basic approach would be we can trace each handle creation and keep a couple of handle and file name and remove this couple when the handle is closed. it's not really the best way. What we choose is to perform the introspection of the handle table that is specific for each processes. So you have two kinds of handle tables. The direct one, which is limited to 501 and 11 handles, and the an indirect table handle that allow you to have more than that for a process. So when you have understand this construction, you are able to convert a handle value to its internal object. So if it's a file, you will get a file object structure, and from this you can find the file name, for example. So in conclusion, we had three objectives. The first one is to stay still C. I think we didn't do anything to the virtual machine, so the guest still an installation from scratch. So you don't have to install or enable any kind of cooperation from the guest. The hybrid approach is made by Python, by the way, so you don't have anything to do. And the simplicity is maybe the most difficult part. The tool is on GitHub. I think I didn't put the, yeah, see. You can find it on this URL, and feel free to ask a question. Meanwhile, I do the last demo, which is just analyzing WannaCry on the fly. WannaCry need to be run with administrative privilege, so let's go. It's quite slow, so as you can see, we have some information on the fly. It could be maybe slow because when a write attempt is made, the file is written on the host, so you can get it for further analysis. Thank you. Yep.
This is really cool, first of all.
Thanks.
So you mentioned, or what does it support for guests? Is it just Windows 10 right now?
Yeah, for now, the framework was intensively tested for the RS2 build, just because we had to develop it. But the abstract layer would allow us to follow the next build of Windows more easily. So we have a core framework that is more stable. So now we can focus on the OS helper and follow more build.
And how about older versions of Windows?
Sorry?
Older versions of Windows?
Yeah, it could be cool. Yeah,
Okay.
there is some. Yeah, the architecture of the framework is not a limitation to support any kind of version of Windows, but it was mainly developed for Windows, so there will be maybe some work to do if we want to support other operating systems like macOS or Linux. So this is the counterpart.
Yeah, and so it's outside of the VM, but you'd still have to make the VM itself stealthy, right? Like you couldn't install guest editions and stuff. VirtualBox signals would still be there for anti-VM detection?
I've installed the guest edition tool, but just for resizing the screen. There is no need for the VM to be the guest to be cooperative. So you can run. Actually, you can run. We didn't focus on the stilc of the VirtualBox. So if you want to hide a VirtualBox from a malware, for example, you have to apply another patch to hide some artifacts. So this is not the purpose of the framework.
Yeah. Okay. Thank you.
Thanks.
More questions?
Thank you.